Hello, everyone. So let's face it, our digital activity has never been that intense. It's growing fast, and we'll keep doing so if we don't change our behaviors. And we have to, because that massive online activity results in a disastrous footprint. Knowing that aimlessly browsing on Facebook or watching countless hours of Game of Thrones on OCS is not as innocent as it may seem, how can we adopt sober digital practices? To discuss about our ability to reduce the physical impact of digital, please welcome John Laban, Reset Catalyst at the Open Compute Project, and Jean-Marc Jancovici, President of the Shift Project. Warmer welcome. So for a start, Jean-Marc, John, could you tell us a bit more about what you're doing with the Shift Project and the Open Compute Project, and what is a Reset Catalyst? Let's start with you, John.
Well, thank you very much for turning up and listening. I'm really surprised by the size of the audience. Just a question. How many of you are aware of the Open Compute Project?
3, 4.
It's pretty good. It's 3 people. That's nice. Well, it's quite interesting. There's a French company that's one of the fastest growing companies in France that's very heavily involved in this. Last year, they employed about 13 people, and they were selling 1,000 computers a week. So there's good opportunity in this as well as carbon reduction. But my role is to go around talking to people and trying to encourage the adoption of open source hardware for computer centers. So if you use apps like, people use Facebook in this room? Any Facebook users?
Oh, come on.
That all works on open source software and hardware. All the Microsoft infrastructure works on open source hardware. So that's what I do. I just try and encourage people, make them aware, and then to move into it, because there's huge benefits in terms of carbon reduction. An open computer will use about 50% less energy than a traditional proprietary computer. So that's me.
What's you, Jean-Marc?
Well, the Shift project is a pain in the neck. We try to encourage moving from the present economy to a low-carbon economy, basically. So we are a business NGO of a certain type, trying to advocate that our best bargain right now is to decarbonize the economy. That's basically what we do.
Okay, that was fast. So
you asked the question.
Yeah, sure, and you answered it. We've seen that the share of digital in greenhouse gas emission has grown by half since 2013, from 2.5% to 3.7% of total global emission. But we need some context and some scale here. So what other source is that polluting?
Well, the first thing is that in order to know whether it's annoying to know if the greenhouse gases emissions rise, I think I have some slides that can come up. That's it. We have to know exactly where we should go regarding greenhouse gases emissions. So this is a graph which is taken from the last IPCC report. Is there more than 3 people in the room that have heard about the IPCC? Yes, OK. That's not that many. So the graph here says that the response of the climate system to cumulated emissions is linear. So basically, you look on the upside horizontal axis at the cumulated emissions of humanity, and you get on the vertical axis the temperature increase that we will get in 2100 compared to pre-industrial times. It's very simple. At the end of 2017, okay, we had emitted that much. That is 2,200 billion tons of CO2. And so we have already committed to 1.5 degrees of global warming. That will come at the latest in 2100 if we stop emitting tomorrow morning. And of course, if we don't stop emitting tomorrow morning, we'll get them sooner. But I mean, the 1.5 is already embarked in the past emissions, because we have to wait 10,000 years for CO2 for the atmosphere to get rid of a surplus of CO2. 10,000 years. Okay. If we want the 2-degree objective, then we must limit the cumulated emissions to 3,000 billion tons of CO2, of which, of course, 2,200 have already been emitted. It means that 800 remain. That is a third of what we have already emitted, with a humanity which is, in rough figures, 3 times more numerous. Okay, that's the challenge. That's the 2-degree challenge. Basically, it means that CO2 emissions must be divided by 3 worldwide by the time the youngest people in this room are my age. Okay, by the time my kids, don't laugh, because you could be the age of my kids. So almost by the time you are my age, they should be divided by 3. That 2 degrees, okay? So now the question is digital compatible with this? So we all think that digital is dematerialized, okay? But just for the digital system to operate, we need mines, which are not dematerialized. We need metallurgy, which is not dematerialized. We need oil industries and chemical industries, which are not dematerialized. We need glass industries, which are not dematerialized. We need extra pure water. We need assembly. We need public works, because we need factories and we need transportation. We need transportation means. Of course, we even need to launch satellites with rockets. And we need to power the whole thing. And 40% of the electricity on Earth comes from coal power plants. And coal power plants alone represent 20% of the world greenhouse gases emissions. Okay. So the result is that when you manufacture a computer, you have emitted 0.5 ton of CO2 into the atmosphere. So you think it's dematerialized because when you have your computer on your knees, it doesn't emit any smoke. Okay? It doesn't smell, or it shouldn't, at least. And so you think that it's perfectly clean. But the fact is that it is not clean because you had to manufacture it. And if you look at the overall emissions of the digital system, actually running the data center is only 20% of the issue. And by the way, you don't sort electrons in the socket of the data center, so buying clean energy, maybe we'll discuss that later on, is actually an illusion. You don't buy clean electricity. You buy what comes from the grid, that's it. And you see that manufacturing the device is about half of the carbon footprint of the global system. Now, with time, that's one of the particularities of IT. In many, many industrial sectors, it happens that with time, things improve. For example, in manufacturing industries, globally, you need a little less energy today than yesterday, for example, to crush a piece of steel. It happens that in the IT sector, it evolves the opposite way. The carbon content of a device today is superior to what it was 1 year or 2 years or 3 years ago. The carbon content of $1 of added value in the IT system, in the IT industries, is superior today, is greater today than what it was a couple of years ago. It's increasing with time. Okay? And here you have the example of Apple device. So as a result, the carbon footprint of the IT system, the global digital system, was 2.5% of the world emissions a couple of years ago, which is the equivalent of the air fleet emissions of the world aviation. Okay? Today, it's equivalent to the truck fleet in the world, 4%. And in a couple years, in a business as usual, it's going to be equivalent to the car fleet in the world. So it's growing by 10% per year, where it should decrease in absolute figures by 4% per year in order to be compatible with the 2-degree objective. So basically, there's a 15% per year gap between what should be done for the IT to be truly a dematerialized industry and what is really happening. Here you have the world GHG, greenhouse gases emissions, since a century and a half ago. The digital industry started there. Obviously, you don't see a change on the trend. Actually, what you see is an acceleration of the rate of increase and not at all a decrease of the world emissions. So the idea that there is tech for good, that is that globally the digital industry is going good in the rest of the world, is not true. Because otherwise, you should see something on this curve. You should see a slowdown of the rate of increase, whereas you see exactly the opposite. Last thing, in a computer, you have 40 to 60 metals, different metals. Most of them are not recycled and will not be because they are present at a concentration which is much, much smaller. Much too small, sorry, so that you can recycle what is included into a computer. So basically, recycling a computer is getting back copper, gold, silver, tin, and that's it. The rest, you don't. So what you have with the device that you buy is that you have an 18 months, on average, lifetime between what you have on the left and what you have on the right. Okay. So in one word, not sustainable at all.
Okay, so this is not sustainable, but we can act on the 19% that are the data centers. We have various sources of pollution and various elements that are polluting, but let's focus on data centers, or computer centers, as you call them, John. What can we reduce by making them greener, and how do you make them greener?
Well, firstly, I am in total agreement with this man about what he said. And it's the reason I gave myself this title, Reset Catalyst, is because the difficult problem is changing people's intuitive mindsets. Let me give you an example. I go and talk to lots of big banks, and I try and encourage them to use these kind of vanity-free, low-energy solutions. And I did a workshop for one of the biggest UK banks. It's a huge bank. And they did a calculation, and they worked out that they would save £20 million a year on the electricity bill, plus all the carbon reduction, if they just adopted these open source vanity-free technologies that the hyperscalers use. But did they do it? No, they didn't do it, because there's another consequence that ties into all this with these new kind of, I even have a new word for it. I don't use the word disruptive anymore. I use the word rumperdis, because open source technologies are more than disruptive. A consequence of this big bank adopting these technologies is they were going to substantially reduce their workforce by about 80%. Now, the chief information officer would have lost his department. So there's lots of kind of fingers that you need to be thinking about all the time. But I'm very, very motivated to make change. And let's give you some examples of some of the changes that open source software has done. If you run open source software on traditional computer hardware, you can reduce the amount of physical hardware you actually need easily by 80%. Because on a typical server, a computer, you're only running an average utilization, generally in an enterprise, a big bank or a government. Governments are the worst. You might be looking at an average utilization of less than 10%. Now, what open source software does, it puts more workload on a single machine, ramps that utilization up, and therefore you get more effective use of the hardware. And you can eradicate, in most enterprises, and I can guarantee for all the European Union data centers, you can eradicate 80% of all the hardware. Now, one last point. This small French company who's selling thousands of computers every week, or were when they were bought, they're selling a lot more now, all of these computers were repurposed computers from hyperscale data centers. None of them were new. Because if we're going to address all the embodied carbon, we have to keep using this stuff. And how many people are aware of this happening, that these hyperscale computers are being used in big enterprises? There's a very big enterprise in Paris. Anybody heard of Criteo? They use this stuff, and they use masses of it. So the French are leading on it, but the problem we have in open source, we don't have big marketing budgets. I'm not an IBM that can spend a fortune on marketing. It's just little me and trying to get some enthusiasts and some champions to help. That's my bit.
If we change the perspective, in your latest report, Jean-Marc, you talked about digital sobriety. What is it, and how can we, as individuals, achieve it?
Basically, it's extending what has John said. That is, buying as little the smallest amount possible of device and keeping it for as long as possible. Basically, that's digital sobriety. So it's not increasing the number of objects that are connected. It's not increasing, it's not going from 4G to 5G to 6G to, I don't know, to 3PG or whatever. It's not increasing the size of screens all the time. So it's basically trying to live happily ever after with what we already have and decreasing the size of the hardware that we are using, basically.
But people, are they willing to do it?
I'm not sure that people are willing to end in a generalized chaos that we are heading to with all the environmental problems that we have. So basically, in order to make a choice, you have to know the terms of the choice. Today, people know the term of the short-term choice on one hand. I'm going to have my screen in the underground, fine. But they generally don't know the alternative, which is this goes along with the fact that we are going to have a very high invoice to pay without the means of paying it. That's the problem. So there is a big disymmetry between what people know regarding tech and what they know regarding environmental problems. And regarding the marketing budget of IBM or others, what I can see is that people in the tech industry are not really eager to finance initiatives so that people know really what's going to happen with climate change. Finance plenty of things, but not that.
But we see that the knowledge is bursting, and this topic is more and more covered by the medias and stuff.
There is a difference between talking a lot of something and talking well of something.
Can I just add a couple of points? Because this is a big, complex problem, climate change and the decarbonisation of the grid. The intelligent grid in terms of IT, the energy grids. The biggest machine man has ever made is the internet. The internet is an open source project. The biggest puzzle that man has ever solved is the genome project. That was done in an open fashion. During the development of those technologies to solve that problem, all the information that every researcher gathered was put into the internet, into the public domain, so everybody could benefit. So you got from this position where, if you look back in about 2001, the cost to map a human genome was $100 million. Today, it's less than 1,000. And what's behind it is the open source communities that have made this happen. Now, if we're going to save climate change, we need this kind of community to make it happen. And it's really quite disgusting that computer centers do not even define what their scope 3 reporting structures are. And their scope 3 is all this embodied carbon. They don't even report on it. Directly they start to do that, and we get a little bit of legislation coming in, perhaps to force that, we'll start to see a change. Now, you might not know this, but in March next year, there's new European legislation on the energy efficiency of computer servers in data centers. So that's a good move.
Okay, we're out of time, unfortunately. If you had one last advice for our audience, what would it be?
Regarding what?
Regarding sober digital practices.
I would just say that it's a serious subject. Not just a gimmick. It's a serious subject.
And when I come and sit in these kind of conferences and talk to people, I just want to leave people with just one new thing in their head when I leave. Could you just help me? Have you learned one new thing today that might be useful for the future? Anybody? It's been worthwhile. Thank you very much for your time.